Hey guys, welcome back to Ox Tools. I'm Tom. So we're back on the Meatloaf here. So we got a few cool items to show you guys and some things to demonstrate and talk about. One of which is this here. Got a lot of interest in these bearing housings to work on this, so there'll be a lot more of that kind of stuff coming. I got some real interesting projects coming up. You guys are really going to get a kick out of this. And so let's take a look at some stuff and let's go walk about around the shop. I got some neat stuff to show you, and we'll get going on this thing. Okay, so we got this little guy right here, and what it is it's a micrometer that I got off eBay. And what I want to do is I want to start out by showing kind of a normal 0 to 1 inch micrometer, so 0 to 25 millimeter micrometer. And so this is a Starrett, what is that, a number 230, and this is kind of the average size, you know, 0 to 1 inch micrometer here that probably most of you guys have. And then the other one I want to show you here is one of my little favorites here, and this is a 0 to a ½ inch Lufkin, and it's just a little cutie here. And this one's actually kind of handy. Sometimes you have a tight space you have to get into, and this one will sneak in there and get in there. This distance is a little shorter from the anvil face to the back here, okay? And it's just thinner along here, so sometimes this one's kind of handy. And it's just so it's cuter than a speckled pup, so you can't resist something like this. So now you guys know how much I like tools, right? So let's take a look at what's in this box, because you guys actually, this is more appropriate. Let's take a look at that. Boom. So this is what we call an A-bomb micrometer here. Let's pull it out of the box and set it up for size. Now this is a Starrett 238, I think is the number on this. Yeah, 238. And it's their heavy duty micrometer, and that's no baloney there. I don't know, this thing weighs a ½ pound or something like that. But you can see physically the size difference there between these two. And this is also a 0 to 1 inch. A friend of mine showed me one of these a while back, and I knew they were around, but I'd never seen one in the flesh or played with one. And once I saw it, it was I think I needed to have one. So anyway, I waited patiently on eBay for one to come up for a good price. And this one had a little bit of rust on it, and it was kind of dirty, so I don't think folks were too interested in it. But the satin chrome wasn't pitted, and it actually looked pretty good. 35 bucks plus some shipping. So I thought that was a pretty good deal there. But anyway, that's the Starrett 238 Big Mamaluca micrometer. So I thought you might get a kick out of that. Okay. So this next one here, this is a little viewer appreciation gift from Southern California. This is from Paul Alfaro, and he's down in the land of McMaster Carr down there in Santa Fe Springs. And he made this little thing for me and sent it to me. And it's a little kind of a pocket keychain, but it's a level, right? And we were talking about levels earlier, and here's another one, and it's pretty cool. He machines these on a little grizzly lathe, and actually, you know what? I don't think I got from him how he does the. I wonder if he stamps those. Yeah, they're slightly raised, so he might stamp those. I don't think that's cut. If he's stamping it, he does a really nice job stamping those. So anyway, it's a cool little bubble level, and it's got one of these little quick disconnects on it, which is kind of neat. And he makes these and gives them away. So and this is one of my favorite parts here. This looks like just like a key ring here, but what this is this is a Smalley spiral retaining ring, and these are really nice retaining rings. I used to use these a lot when I was designing things that had a lot of snap ring grooves in them. They're pretty cool because you don't need a particular tool to get them out because they have a little notch. You can just hook them and pull them out. And if you, as you notice, it doesn't have a gap in it. So these are full circle. So from a thrust aspect, these can take a little bit more than I think a standard snap ring like a True Arc or one of those. Okay, so and they're kind of neat to put in too. So so if you need a fully enclosed snap ring type, take a look at these Smalley rings. They're pretty good. Anyway, Paul, thank you very much. This is a really nice little handmade gift. I love it. And I got to find some keys to put on that or something. Maybe I'll put my my forklift key on there or something. So that's pretty cool. Nice finish. Nice work. It's got a little plug in the end where he inserted the vial. So, and looks like it works. It's on the level. Thank you, sir. Appreciate it. All right, so this next one here, you guys have seen this before. This is this Starrett metric cylinder gauge or bore gauge, and this was donated to us by Sam Gable, and this is I got it. I sent it back to. Oops. I sent it back to Starrett, and I got the gate or the indicator part of this repaired at Starrett. That's the repair order. And they sent it back in a nice little Starrett box, you know. Like Phil Kerner says, all kinds of good things come in red Starrett boxes, so it's true. So anyway, this is going to this Morrisville State College, their mechanical engineering technology program, and John Geis is the guy that's going to get it. He and I have been talking on email a little bit, and you know, it's summer session, so the students aren't there right now, so I didn't send this out right away. But he said, hey, you know, if you haven't sent it out, it might be nice if you did a demonstration on how this thing is used. And I said, heck, you know what, that's actually a pretty good idea. So I thought you guys might get a kick out of that. And also they can show the video in the class, show people how to use this thing. So I thought we'd go ahead and do that. So I got a sample victim set up here, and let me change the camera around, and we will get in here and try this little monkey out and see if it can talk. Okay, so here's our victim here, and it's a piece of DOM tubing, which stands for drawn over mandrel, and it's about what do we got? 117 millimeters. Is that what I'm seeing there? 15, 17, yeah, something like that. So a little over 4.2 inches. It's about the same size as a 427 Ford bore engine. You know, 427 cubic inch Ford. So the way we use this thing here is, this thing doesn't have the ability to take the actual dimension directly, okay? What it can do is tell us something about the relative condition of the bore, if it's egg-shaped or if it has taper and things like that. So the way this works is it has a little, let me loosen it up, it's got a little rod that comes out, and then what we do is we extend that rod. Oops, I think I got to use the longer one here. I got to use the longer one. We extend this rod out and then lock it, but let's put the longer one in, and it keeps the longer one in the tail here. Yeah, okay. Let's put that in there. And it's got one end that's got a little spherical end on it there, and then it goes in the bore. And what we do is, these legs here are spring loaded, okay, and you can see that they're moving, but the indicator is not moving, okay. What these are these keep the measuring stylus perpendicular to the bore. This is actually the measuring button here that comes into contact with the bore, and then this side is on an indicator plunger here and can move. Okay, so these are just this thing's got more degrees of freedom than an octopus, and that keeps it in the bore and takes away some of that operator feel. Okay, so what we're going to do is we're going to shove it in here and compress this a little bit. All right, let me lock that down, and it's got a strong enough spring in that it keeps it against the bore straight and even supports the weight of the unit if you're careful. So what we'll do is make sure that, yeah, you can kind of see that. I'll probably change the camera a little bit. So what I'll do is I'll zero this out now. I'm going to move the camera here in a sec. All right, so now, it's just barely holding on there. All right, I think it'll stay right there. This had some rust on the bore and I had to polish it a little bit so it was smooth so we could get some good readings. But I'm going to move the camera so we're kind of looking more down at it, and you guys can see that, and then we'll show how the micrometer part of this equation works here. Okay, so we're kind of down the bore here, and I can pull it up and I can push it down, and I keep my eye on that gauge. Now, I haven't used one of these a lot, so just kind of bear with me there and let it settle. And if I slide it down, I see it's moving a few hundredths of a millimeter. Let me come up close to the top here. Okay, and then I can, if you're careful, I think you can rotate it around and look for egg-shaped situations on the bore and check it. Okay, so we've zeroed the instrument now, so we can actually pull it out of here. You can lock the plunger, I think, with that one. Let's pull it out of there. See, and it stayed. It stayed. So now we'll go to stage 2, where we actually get the actual measurement over the stylus here, and see what that bore actually is. Okay, so we've pulled this out of the bore now, and this doesn't give us a measurement. All this does is tell us relative condition of that bore, so we can measure taper or out of roundness or things like that, but it doesn't really give us a dimension. It's just a relative difference from some starting point. So now, to get to a size, what we need to do is measure over it with a micrometer here, okay? And a micrometer that we calibrate on a length standard here, okay? So this is how we get to a measurement. This is a 100 millimeter standard there. So it looks like we need to change anvils here. This is a 50 to 150 micrometer here, millimeters, and it reads to a hundredth of a millimeter, okay, 0.01 millimeter. And for those non-metric folks out there that are watching this, that's about equivalent to about a half a thousandth. It's just shy of a half a thousandth. So so let's change the anvil here. And it has a little adjuster, and that's one of the anvils, okay? And I think it's just going to be this next one up here. Let's see. Yeah, that looks like the one. Okay. So we make sure that those mating surfaces are clean. And it's got little grooves in it so that if you rotate it, the crud goes into the grooves if there's any there. And then we secure that. Okay. Okay, and then what we want to do is we want to now calibrate that. Okay. All right, it's pretty close. I think that's going to be fine for what we're doing here. So there's two ways to calibrate it. You can move the nuts on the anvil here, or if it's just off a line or two, you can rotate the thimble a little bit. to bring it into calibration. But this one looks pretty good. All right. So now that's a 100 millimeter gap there. So let's see, how do I want to do this here? It's a lot of business to hold on to here. Maybe this will help. Get that off of there. All right. Open this up. So now we're going to measure over the button and the stylus here, which is locked in. Hold on to this mess here. Oh, opened it up pretty good. And my indicator moved a little bit, it looks like. The little lock thing didn't quite hold on to it there, so I'm just going to wind it in until I'm back on 0. Right there. Okay. All right, let's read this thing. So it's 100 plus 5, 6, 7 and a half, 20, 24. So that's 10774. 10774, is that right? 5, 6, 7, 50, 5, 6, 7, 4. Yeah, 10774. I don't read metric micrometers that often, so forgive me there. So that's what our bore is here in this guy, and that's how you get back to an actual measurement. And this one is just telling us. So if you wanted to plop this in, so once you know what this is kind of set at, we can go back in all the different cylinders in the engine and compare all the bores, the multiple bores that are typically in an engine, right? And then you can run it to the top, you can run it to the bottom, and you can see taper, and that shows up here as a plus or minus condition from some nominal number. So now the other thing you can do is you can preset this. You can preset this at some known dimension, say 107 millimeters or something like that, and then go into those bores and say, oh my God, it's it's 2/10 out. And the smallest one is this, and the largest one is that. So that's another way that you can use this particular instrument here. Anyway, that's about it, and that was kind of cool. And this is going to Morrisville, and you guys enjoy this tool and use it well. It's a really nice tool. So thanks for watching. Well, you guys would be sorry to hear that I broke my Johnson. The motor on this thing, it was kind of I think it was an aftermarket motor that somebody put on, and they did a kind of a poor job of it. Well, I decided to go on Sparkabout, and it died on me. So this is going to be an upcoming project, actually fairly soon, because I needed to use it. So I ordered a new motor. A slightly larger motor, and it's a 3-phase motor, because my plan here, and I ordered the variable frequency drive too, so we're going to mount a new motor and a variable frequency drive on this to get this going. And what that'll allow me to do is have a pot here where I can change speeds on this without farting around with belts and stuff like that, like the previous setup. So that's a coming project. I'm sure you guys will be interested in it. There's a lot of curiosity about remotoring tools and using these wonderful, inexpensive variable frequency drives that are available. So that'll be a little upcoming series on getting this thing running again, so I can cut stuff, because I got a lot of stuff to cut. So anyway, stay tuned, guys. Okay. So here's the other one I wanted to talk about. So I've been gathering some materials for this, and I think I showed this in a Meatloaf a while back. And this is it's an Enerpac toe jack, but it's missing the moving part of the jack. So I have the cylinder, I have the pump, it's got the little feetsies on it and everything, but I need to recreate the moving part here. Well, the fellow YouTube creator, James Kilroy, has one of these jacks, and he was kind enough to take some measurements for me and get me some dimensions of the missing bits that I have here. And I'm going to do it a little different than stock, just because of the materials that I have. And so actually I have a little chicken sketch here so you guys can see that. Let me make sure that I don't blow out the exposure there. So anyway, that's kind of the general idea there, what it's going to look like. Okay. And so this is going to be an upcoming series here, so stay tuned for that. That's pretty cool. And this is this design, you know, it's simple. It's got a flat plate, it's got sides, it's got some guideways, and it doesn't have to be an Enerpac cylinder. This could be a cheap bottle jack that you just slip up inside there and off you go. So guys that are really thinking about building one of these, this is a very handy tool, trust me. And pay attention to this series if you want to build one of these, because this is a decent way to do it with some tube and you know, just some plain steel pieces. So anyway, that's coming up pretty quick here, guys. Stay tuned for that. Okay, so this next one, now I've showed this before. This is a level that I bought off of eBay, and I've been hunting for one of these for a while, and I found this one in the last year, and I showed this before. And this is this Hilger Watt level here, but it has an adjustable vial, so I can vary the tilt. Okay. So now this one division here is about 1 minute of angle. So each one of those divisions is 1 minute of angle, and one revolution of this is 1 degree. And I was pretty proud of this thing. It's this thing will read to 1/10 of a millimeter per meter. Okay, or 1/1000th of an inch in 10 inches. Okay. And you know, it's just a very nice instrument. Okay, it's just got a nice look, it's got a nice smell, it's just lovely. Okay, none of the knobs are missing, etc. Okay, there's that thing. Okay, I took it to work to show a friend at work who's kind of an instrument buff, and he said, "Oh, okay, I'll bring my level in." And so he brought his level in and kind of blew this one out of the water. And what's interesting is I never knew that particular instrument existed. I wasn't familiar with it. So I was fascinated, and I did a little research. And guess what? I know you guys know what's coming, right? Let's get this one out of the way here, because we have a new one. They came all the way from Portugal. I bought it off eBay, and from a gentleman in Portugal that's selling off a bunch of old stuff. And he's a nice guy, and he packed this thing up really well. Let's see which way. I guess I'll bring it up like this. And that's this one here. It's very similar. It's got a V bottom on it. Okay. And this is a pretty special piece here. Okay. Let me spin it around so you guys can get a look at it. And this is a Hewitt. H-U-E-T, and it's made in France. It says Hewitt Paris and a little serial number. Okay, and what this is this is a coincidence level. Okay, and what it does is it takes the bubble and it splits it in half, and then you're actually comparing the opposite ends of the bubble to one another. So you have very, very, very good discrimination. And then it has an adjusting thimble here, and this one happens to have a differential screw in it, which is pretty cool just in itself. Okay, and this one of these divisions, okay, is a 1/100th of a millimeter at 1 meter. Okay, 1/100th of a millimeter at a meter. So for us inch guys, that's 4/10,000ths of an inch at 40 inches. Okay. So it's roughly 10 times more sensitive than that other level that I just showed you. The other level, right? It's relegated to the inaccurate pile now, right? So that one can can resolve 1 minute of angle. This could each one of those divisions is about 2 seconds of arc, okay? And that's what makes this very special. Now, I'm gonna try to get up nice and close so you guys can see the split image bubble, which is kind of, they have a set of prisms in there that separate the image, and then in fact it kind of looks like that, right? My 2 fingers lining up with one another. A lot of guys might be wondering what this is here, and this is basically just a reflector, so any light that's coming in gets reflected up into the optics here so that you can see it a little bit better. So it's just a very nice piece. From a design standpoint, it's kind of boxy, and it's a little tall for its length. It doesn't have that kind of sleek, low-level look, right? But its sensitivity makes up for it. So I was playing around with this thing on the milling machine, and I zeroed it up, and then I put my finger on the milling machine, down at the end, and the bubble went. That's how sensitive this thing is. So let's see if we can get a good image down the trap door here, so you guys can see that. It's just cool. Okay, so there we can. Here's where we're looking, guys. Okay, so there's the image is partly in view there. So I'm going to adjust the knob here a little bit. Oh, I'm going the wrong way. And you'll see the other half of the bubble coming into view there, kind of on this side, the right side there. It's kind of hard to see what's going on for me. I gotta get. I can't see past the camera. Okay. So getting close. All right, let it settle. All right, that looks pretty good. Now I'm just gonna put my hand on the end of the mill table here. Oop, bump the camera. So I'm putting, I don't know, maybe a pound or something out here on the end of the mill table. I'll let off, and I'll slowly drift back. Anyway, that's a demonstration of the sensitivity. Now I have a flashlight. Pointing in the thing. Let me rotate the. This is the reflector. I'm just moving the reflector now, so you can kind of see that. Anyway, you can see the split down the center. Okay. And then these are just rough leveling vials here. Pretty cool, huh? Okay, so I was at the antique store today, and I found these Crowder lineman pliers here, and I've always liked the Crowder pliers. I mean, look at this Art Deco grip surface in the handle, and their forging is always very, very crisp and nice, crisp, sharp edges. And then they have, hopefully you can see that, these fine serrations on the jaws. And these are in pretty good shape here. There's no notches in the cutting edge. They get a little bit of weaselness on the end here, but not much. It's not bad. The funny part was, apparently, this isn't the first time a pair of these has followed me home. And I went in my drawer and I started poking around because I knew I had some itty bitty ones here. Okay, and these are, I think these are real old. You can see the pattern's a little different here, and the forging's even better. And for whatever reason, the edges are just wonderful. And I mean, just look at that angle there. It's just like tink tink. It's a facet, It's like it's. Now these, the tip was a little screwed up when I got them, so I kind of adjusted them a little bit. But this is the pair of pliers I kind of fell in love with Crowder, right? Okay, so let's keep going here because, whoops, I got another one. And whoops, I got another one. And whoops, I got another one. And finally, so 1, 2, 3, 4, 5 pairs of a single type. And this wasn't on purpose, guys, okay? It's just, you know, you don't remember what you have in the drawer until you go back and you go to put this one away with all these others, and then you see all the others. So anyway, these are -8s, -7s, and it doesn't have a size on it. These are -5, so that means there's a 6 that lives in there somewhere. I don't know what I'm going to do. And then these. So let's put those on here so you guys can see them all. I don't know if it's out of the frame or not. Anyway, Crowder collection. Just good looking pliers. Like I said, look at that. It's just, I mean, attention to detail. It's just really nice, huh? Nice to see it in old tools that still work.